Simplifying rational expressions. If we have a rational expression and we want to simplify it, what we're going to be looking for are perfect squares that we're going to want to take out of it. But first off, the only time we can do this is if there's only a single term. So for instance, if we had x squared plus 9, there's nothing that we can do with this because we have two terms underneath the radical. Our only option, if we have two terms, if we want to do some simplifying, is if we can factor. But since this polynomial doesn't factor, there's nothing that we can do. Okay, so let's look at how we go about simplifying rational expressions when we do have a single term. So for example, say we have square root of 200, and we want to simplify this down to as simple as possible. Okay, so what we're going to be looking for are any perfect squares that go into this number. So let me write down a list of perfect squares, and then we'll see if any of them go into 200. So 1 is a perfect square, but it's not going to do us any good because 1 goes into 200, but if we divide 200 by 1, it's not going to do anything. 2 squared is 4, 3 squared is 9, 16, 25, 36, 49, 64, 81, 100, and so on. Okay, so what we're looking for, do any of these numbers go into 400? And you can either do it all at once, or you can do it little pieces at a time. And so let me show you little pieces at a time, and then we'll go back and redo it, doing it all at once. So first off, just going down the list, we don't care about 1. 1's not going to do us any good. So we're going to start at 4. Does 4 go into 200? And it does. 200 divided by 4 is 50. So we can write this as square root of 4 times 50. Okay, 4 is a perfect square. And now with what we have left, do any of these numbers over here go into 50? And so the next on the list is 9. 9 does not go into 50. 16 does not go into 50. 25. Oh, 25 does go into 50. So 50 divided by 25 equals 2. So now that this is, we're going to be able to split that up. So this is going to be 25 times 2. And now looking at what we have left, 2, nothing on this list goes into 2 except for the 1, which again doesn't do us any good. So now we have this broken up as much as we possibly can into perfect squares. And so now each perfect square is just going to come out of the radical. So square root of 4 is 2. Square root of 25 is 5. And the 2 gets left behind. And so this ends up being 10 square root of 2. Okay, now that's the step-by-step approach to it. We can get there in one big leap if we look at this list and say, oh, what's the biggest number on this list that goes into 200? And we see, oh, 100 goes into 200. So immediately we could start off this by saying square root of 200 equals square root of 100 times 2, which is going to be 10 square root of 2. We get the same answer, but we do it in fewer steps. Okay, so let's look at how this works when variables are involved. So for example, 20x to the 5th, y to the 8th. The number, the coefficient, will behave just like it did in the previous problem. We're going to be looking for any perfect squares that go into 20, and we can see that we have 4 times 5 for 20. So 4 goes into 20. It's a perfect square, so we pull that out, and we can write 20 as 4 times 5. For the variables are actually easier than the numbers because what we're looking for is the largest even exponent that's less than or equal to the exponent that we have. So in this case, x to the fifth, we want the largest number that's less than 5, that's even, and that's going to be 4. So we're going to write this as x to the fourth times x. And y to the eighth, that's already an even number, so we don't need to do anything with that one at all. We can leave it. And so now we have it broken up like this. And then the 4, the x to the fourth, and the y to the eighth are our perfect squares. Let me move those to the front so we can see this. Now, you don't have to take as many steps to do these problems, but this is the process that we're going through. So it's going to be 4x to the fourth, y to the eighth, times 5x. Okay, so these three pieces here, the coefficient, the x term, and the y term, are all perfect squares. This 5x is what's going to be left over at the end because there are no perfect squares that go into any of that. Now the 4, square root of 4 is 2. X to the fourth. Now recall that a radical, a square root, will divide an exponent by 2. And that's why we needed it to be even, because 2 doesn't go into the odd numbers. We need to make sure that we have an even number. So x to the fourth, square root of that becomes x squared. And y to the eighth, when we cut that exponent in half, becomes y to the fourth. And we're left with 5x. Okay, so 20x to the fifth, y to the eighth, all underneath the square root, simplifies down to 2x squared, y to the fourth, square root of 5x.